off and trying to get a every other month, every quarter network nerd meetup where we could invite people, and then Luca of ntop and us at Kentik, we've been working together, and even before Kentik existed. And last week there was a conference called FlowCon. Has anyone heard of FlowCon? Been to FlowCon? So it's nerds that think about network flow analytics. Mostly it's actually relatively closed-minded people that think that flow is only for security and that you must unsample it and that you must use Silk from the government or from Carnegie Mellon, but funded by the government, and most of their focus is around that. So Luca came to give a talk about his roadmap, some of their technology. I gave a talk about how we think you can get data and use data more than just the way routers and switches are doing it today. And we thought the focus would be on ntop. Luca, give him a chance. I know we have at least one. At least one ntop user in the room, probably some more. We have a couple users, but we're just going to talk about sort of how we think what Luca is doing is interesting. And then as I said, lots of QA. Some time to talk. We can talk about other folks, other things people are interested in as well. If there's time, maybe a deeper dive on some DDoS scrubbing, that technology that ntop's developing as well. And if it's interest, then we'd be happy to take feedback, try to find some people to talk next time. I think we actually have 2 people in the room that on their own would be interesting, from Wireshark and Inmon, to talk about roadmap at a future meetup and what they're seeing from customers and get feedback. Maybe we'll volunteer you guys, but interested in people that have developed interesting stuff and are still active in pushing the edge. So with that, I'll turn it over to Luca, and you will figure out how to maximize that.
Wow, thank you.
I could do it from the CLI, but
okay. First of all, thank you very much for coming tonight. It's a pleasure to be here. We organized this thing, in a very informal way. So thanks for being here. What is the idea? The idea is that we would like to give you an overview of what we think at ntop it's worth to do this year. We would like to tell you a little bit what we have done for those who have not used our tools, and what are the plans for the 2016. So in essence, first of all, to meet people, to have feedback. Feedback is always very important. It's the driving force, at least for us. We have some ideas and plans, so Avi has discussed about the DOS or other things. You will see that in a moment. I want to give a sort of short presentation, maximum 20 minutes, half an hour, and I would like to hear mostly from you. Your comments are very, very valuable for us. And then, based on the feedback, we hope we can adapt a little bit the roadmap, the thing we have in mind to do, and to do something better next year. So the presentation is divided in steps. The first thing I want to do a short introduction, and then to talk about what we are currently doing. 100 gigabit. And for us, 100 gigabit, it is important because it is a faster speed, and being faster means being more efficient. I don't pretend to think that everybody is moving to 100G this year or next year, but I think that it is important to have a good argument for starting from scratch again and to rethink, the software that we have designed in years to make it more efficient. And just like Avi said before about security, I don't believe that it's important to have flows for everything like we have written, but it is important to know what type of things we are monitoring. Years ago, when Peter Pal contacted me and told me about S-Flow, I was curious about the story of sampling, and I thought that, for instance, that dropping stuff was not a good idea. But then over the years, I thought that actually it was a good idea. So in essence, we cannot think that in order to give visibility to our users, we must see everything, but we must know exactly the important things. We must measure the important metrics we believe that are necessary for a monitoring thing. unfortunately, big data, it's like the mouse or the touch interface. People are used to it. They think, oh, we have infinite room, infinite space. Gmail has started this trend years ago, and they want to save everything somewhere just in case. But this just in case, it doesn't happen all the time. Actually, most of the time, it does not happen. So we are having big systems that are saving everything for no reason, okay? So that is the idea. So let's try to generate flows whenever it's necessary, flows that are monitoring the important metrics, and then go to pickup or go to more detailed monitoring just when there is a good reason for doing that. So this is the thing. Of course, high-speed packet to disk, even though I'm not a big fan of packet to disk, it's a good argument, at least for many users. And how to move to non-IPFix or non-NetFlow protocols, because for me, I've done NetFlow for many, many years, but I think the NetFlow is just a format. The idea is that the flow itself, the concept itself of combining packets together with certain properties. And in addition to that, I will give you a little bit of overview of what we think is necessary to do. So flow by itself does not help, or at least we believe that it's important to do something extra on top of that. For instance, inline policy. Let's start with a short introduction to what we're doing and who we are. So this is a small word cloud I have created using the first page and then some blog posts that we have done. So what are we doing? We're mostly doing network monitoring, but in order monitoring to be efficient, we have started to play with packets. First of all, we have created a module called pfring in the kernel module. In the kernel Linux kernel. This happened in 2003, more than 10 years ago. And then over the years, we have created accelerated driver that was somehow bypassing the kernel, similar to what FPGA-based cards have done. So we support a few of them. Our idea is that pfring should be really transparent. I don't want people to spend too much time with the hardware. I want them to think about what they are doing with packets. Okay, so we take care of the efficiency. Our platform is very simple. We have an API. Open the device, with the device name, okay, and there's whatever, Napatech something, and then forget. We give you packets. It will be efficient. Your software will run unchanged on your laptop or your very expensive server. We are doing flow monitoring, and of course we are doing something that it's important for us because it's a root, in essence, ntop. ntop is a web-based application that embeds a web server for analyzing in real-time traffic information. Some of our stuff has been made popular by other companies. So, for instance, the original ntop was integrating this Cisco N100 or some of other things. So I have done with Cisco, for instance, NetFlow Lite that I don't think it was a good idea, but anyway, so we have contributed to that. Another thing of which I'm instead very proud is a big project I've done with JDSU years ago, where they managed to create a small FPGA, sorry, at the beginning was the prototype and FPGA, then later a chip that stays inside an SFP, so this SFP can be used to generate some sort of flow monitoring. So instead of putting sensors, just replace the SFP.
Is that commercially available?
JDSU used to sell it. It was part of the Packet Portal initiative. Now I don't know if it is still available.
Maybe it's just the NSA that buys them.
I don't know. It was an interesting thing with its limitation. And of course, there is not much RAM. An interesting tool. And then our tools are used to accelerate packet capture and transmission. So, for instance, we have many open source projects that are using our tools for simply being faster. Suricatas, North, Bro, the CERT tools, Silk, YAF, just to mention a few. Okay, now let's go back to the talk. So I hope you now have an idea of what we are doing. Why affordable? This is the title: affordable high-speed sensor everywhere. Okay, from day one, where we have started to play with packets, we thought that network monitoring was considered, unfortunately, by many people as a sort of art. It had to be expensive because it was complicated, it was difficult. Okay, I don't want to say that it was simple, but I'm saying that the price was not justified by the tools. Okay, at least this was my understanding. And in those years, there were fan of NetFlow, fan of SFlow, fan of SNMP, fan of something. Okay, I didn't meet many fans of data. So they didn't think in terms of data, but they thought in terms of I support the Cisco X device that speaks, this very special dialect of NetFlow, blah blah blah. Instead of looking at the big picture, and I started to think that it was time to give more visibility to people without waiting vendors to make the next iteration in their hardware boxes. And then I started to play with packets. And a good example for this is the packet inspection. This packet inspection is considered like what it was considered monitoring years ago. It has to be expensive, it has to be costly, it has to be difficult, you have to pay, it has to be closed source. And this is not the case. So for instance, we have this an open source toolkit we developed called NDPI that we will show later. That I don't want to say it's as good as commercial solution, but at least it's comparable. This for sure. So the idea is that sensors must be affordable because the number of devices is increasing. We cannot believe that we put one monitoring box at the center of our network. We put 400 gigabit network interfaces in some years, and we'll be happy. This is not the case. The devices are everywhere, so we need many boxes and must be cheap. But at the same time, they must be rich in monitoring. Bytes and packets, it's all the stuff. We need them. We still need them, of course, but we need something more visibility. And high speed. What is the meaning of that today? I think that for home and small offices, 1 gigabit is the speed. Whereas, for the other speeds, people are moving towards faster networking. For instance, 10G, I think it's pretty standard today, even because the price of network adapters have decreased quite a bit. Now a dual 10G card without optic costs less than $300, just to give you an idea. And 100G is becoming important, okay? It is still limited. It is still not the focus of what we are doing, but it is important to be prepared, okay, to the next speed, okay? And this is what we are doing. Of course, the lines are not fully occupied. Today, for instance, we have visited a big company that is full of 100G lines, and we look at the picture, MRTG picture, and lines were, in average, used 20–30%. Okay, but they will be more and more used, so more data will come. So it's important to be ready. We cannot simply say that a lot of packets, so many packets, means poor metrics, because people are used to have good metrics, even if the network is running at 100G. And everywhere means that they have to be put on commodity hardware if possible. They have to be deployed in many places, so they have to be cheap. So this is the idea. It's a ballpark. I put some number in US dollar just to give you an idea of what we are targeting. Actually, I believe we can do much better. Okay, especially at 10 and 100G. 100G card is too expensive. The card and the optics today are far too expensive. But at 10G the prices are decreasing. So hardware plus software, I think we can do a little bit better by the end of the year. So this is our goal for everywhere. In order to be practical, I tell you that inside PF Ring we support not just the Intel adapter with our special fast drivers. Now we support also other cards. Some of them are already running at 100G. Soon we start, playing with the new Intel 100G card that has been announced and should be, available this month or next month for sure at a price that is below $1,000 per 2 ports. So it looks like a good thing to play with. And when I said flows for everything and pickup for something, I meant that it is important to give people some metrics, to create some logs, to give them visibility of everything that is enters or leaves the network. Everything, I mean, unfiltered. Because sometimes the firewall is dropping packets that are considered important because they can be an attack or something. So from a point of view, it is important to create logs or give evidence of all the network communications, but then to focus on monitoring on some of them, okay? Because as the traffic increases, so we have to somehow to be focused. But we cannot pretend to do everything. And these are just some numbers. So in case we want to put packets to disk, that again, I believe that is something that is very popular in some markets, but I don't think it is a good idea, because as you can see, the space on disk is growing. Okay, so when we move to from 1 to 4, from 1 to 10, this was already a big step. But going to 100 for this, it is not practical at all to write everything on this. So we must filter. Filtering must be smart. So we cannot say I want to drop port 443 because it is encrypted, because most of the traffic today is dynamic. So we must do something interesting. And for instance, last week, like we said, we attended this conference, and I heard people talking about Bro, Suricata, Snort being super fast. But then at the end, you start attending a tutorial, and you see that even for handling a few gigabit, it's a big pain. So we must reduce the amount of traffic that is sent to those applications, because those applications are CPU bound. So it means that they have to do many things. Okay. They can be, very efficient, but at the end, they have to do some work. So, for instance, one thing that we are currently doing is, for instance, we are doing filtering of specific protocols like Netflix or Apple Music. I don't say that these are protocols from the networking point of view, but I'm saying that it is necessary to reduce the amount of traffic that we can send to those tools. And in order to do that, we must be able to filter at application level. So this is one example. Pick up for something. So for sure, not for encrypted traffic unless you are working in a security company. So we must reduce traffic. This is what we are doing with our DPI tool I will describe later. So in essence, we want to generate something that we call augmented flows. So in essence, not just bytes and pocket, but something more than that, that describes what we are doing. Just to give you an idea, for example, for HTTP, I want to give you the host name I accessed. So if you have a virtual host, so I know exactly which one has been accessed. Or if for SSL, we decode the server certificate, so we know exactly where we have been. Or for DNS, I want to give the query that has been made and the response code, just to give some sort of visibility. And based on those tools and in this data, it's possible to think a little bit where to focus, what type of machines are interesting to analyze more in detail. Okay, but again, this has to be done on everything. So in essence, we want to discard some unnecessary protocol, and we want to do full analysis for specific protocol or for specific hosts. In order to do that, we believe that DPI is still a good idea. We know that it's heavy, it's computationally intensive, but we still think that it's a good approach. As the traffic is becoming more and more encrypted, we know that we are facing with some problems. But at the end, we must give some visibility. We cannot really assume that IPs or ports, give us a lot of information, because they are changing. Many services are hosted on Amazon, for instance, and to see an Amazon IP doesn't say too much. So at the moment, we have this open source DPI toolkit called NDPI that we believe is pretty efficient. With 2 cores, we can analyze 10 gigabit of real traffic. But it is not enough, because we cannot afford to run this toolkit at 100 gigabit. So we are developing a smaller toolkit we call macro NDPI that is focusing only on selected protocol, HTTP and sub-HTTP protocol. So for instance, Facebook, we believe it's a sub-HTTP protocol, so it's https.facebook, so just to give you an example. Or that says, SSL, HTTP, and DNS. This is the beginning. And then I would like to hear from you what other protocols we have to add without compromising the performance. So the goal at the beginning, like I've said, is limited to these 3 protocols and sub-protocols. We believe that it's a good start, but because it allows us to filter a lot of traffic. For instance, we want to filter encrypted traffic. I forgot to put SSH. That is also another good thing. At the same time, we give visibility, because decoding the certificate allows us to tell you whether a certain communication has a self-signed certificate, so might be something to analyze more in detail, or if we are connecting to a bank or to a big service. So this is important. We want to provide some metadata, because I said we need visibility. And this allows us to reduce the amount of traffic that we plan to send to our packet-to-disk application, or for instance to Wireshark for analysis, because we have less traffic. Talking about the packet-to-disk, years ago we have developed this tool called end-to-disk, and the companion tool that is called disk-to-end, that is doing reply of traffic at line rate. And Now, we believe that we can no longer have a flow tool here, a packet to disk application there, and another custom tool there, but they all must speak together. So because we have created an index along with the packets, not just pickups, we plan to put flow information, some sort of flow information or protocol information inside the index itself, so that you can filter, for instance, DNS traffic sent to a specific place or a certain flow ID that has been considered interesting using tools like the Kentik tool that allows you to see what is happening on a large scale. Okay, and this also for avoid writing unnecessary packets. The tool that we are developing, this is available in beta at the moment. Also, it's out. It's part of our tools. It's called 100. 100 means 100 in Italian. Okay, 100 is for 100 gigabit because we think that this is the goal. We already have people that are using that, using FPGA accelerated cards. They're able to do 100 gigabit monitoring. I have slides later if you're interested in looking at this tool, how it works. So the idea is that it can combine two 100 gigabit interfaces, 10 or 100. Okay, we are sitting on top of PF3, so we are totally agnostic with respect to the network interface. Cento takes packets, runs this micro DPI. So at the moment, 4 protocols are supported and the sub-protocol, and we generate flows on everything. So at the end, when you see NetFlow collector, or imagine also a text-based collector, so logs. So we want to generate flows out of everything. So it's literally possible using a server and an accelerated card, like an Apatek card, to do that. Okay, over 2 times 100, so we see both direction of the traffic. And also we balance egress traffic towards applications such as Bro or Suricata, just to give you some examples. So in essence, we say this application, it is no longer doing NetFlow. It is doing NetFlow plus something else. So meaning that we want to reduce the amount of packets that we have to process. At the same time, we want to egress packets to applications that are doing in-depth analysis using a feedback channel here on the top. So in essence, if you have your monitoring tools that for some reason consider a specific host or a specific port or a specific application protocol important, we can use this application not just for monitoring but also for egressing traffic to this application. And when this happens, it is also possible to have an optional packet to disk channel, so that you can also write to disk at high speed packets that can be later analyzed with a traffic analyzer in detail. And we believe that the export of non-NetFlow, non-IPFix data, it is important. Okay, you want to export data in many different formats. So at the moment we support JSON, but soon we'll add support for other formats like the Kentik Kflow. The message here is that we are interested in giving and shipping data to consumers. Okay, I don't care if the format is standard or not standard. The important thing is to send data. I think Splunk has been a good idea. Okay, to change a little bit the mind of people that were considering the format is important. Here, I think we have to focus on data, and we also plan to support Kafka. Okay, like we are supporting other application we have developed, because Kafka is used by many people to send this type of information to a big data system. And the message format at the moment is in JSON, but we are trying to find more efficient formats. We believe JSON is good to have and it will be there, but it's open, it's simple to use, but we probably need to find a more efficient format, because sometimes it's a little bit too heavy for processing. Do you want to talk about this part, Fred?
Yeah.
Okay.
Okay. So a couple of years ago, actually more than 1 year, let's say, we started to work on a new project, nscrub, which is the DOS mitigation system. Because a few guys came to us asking for something scrubbing the traffic to their network, because we have very optimized drivers able to do RX and TX at line rate. So it was interesting to create something able to scrub the traffic with a very cheap solution, let's say. So we started this new project, also because it was really, we were having a lot of fun doing this. Yeah. So now it's in production. Actually, it's in beta version, but it's in production. A few hosting providers are using it. In essence, yeah, it's a software with a REST API, which you can configure the software using the REST API or get statistics of what's going on using this API. Okay, probably it's better if you are interested, we can do some offline session where I can explain in detail how it works, because I have a few slides, but they are not in this presentation. The idea, okay, so it's able to scrap the traffic. It can be configured with the REST API. You can read statistics via the REST API. It's possible to export traffic, good, bad traffic, all the traffic based to external applications, or to, for instance, the traffic recording application. It's possible to divide the scrubber into the scrubbing application into virtual scrubbers, so you can define your policies per destination. For instance, if you're in your network you have a few web servers, gaming servers, etc., you can define your policies based on destination. So it has a few features, but let's say what was important for us is to create a platform which is possible to extend this platform using plugins. So we want to create an open platform. For instance, if some customer has specific applications and wants to create its own dissectors, let's say, in order to check specific traffic, or even new algorithms for detecting common attacks, but wants to have, for instance, their own IP on those algorithms. So we want to create it. Yeah.
The diagram seems to imply that it's in the middle of the forwarding path, but I assume instead you actually have two taps, one at the WAN side, one at the LAN side. I'm trying to understand why.
Okay, which tap?
Packets go through and scrub.
Yeah, they go.
Passively.
Yeah. No, it's active.
So
it can work in line, in both directions, or in a symmetric way. So one direction, for instance, with traffic diversion mechanisms.
But only when you need to inspect something. Like you're under DOS attack, you're thinking, okay, what's going on? What's a good traffic? What's a bad traffic? You plant it, for example, via BGP, and then it can filter out what is good from what is bad.
It can work inline, and that's the default.
Yeah.
And we're actually, that's something that we're working on together, is what's the best way to do the diversion support. The default, where it's deployed mostly today, is it is inline, and if it failed, the traffic would stop.
Yeah.
Thanks.
Yeah, it's a scrubbing system. So yeah. Okay, so coming back to CentOP, for instance, it can be deployed. This, I guess there was another slide. Yeah, let's say we have CentOP before monitoring all the traffic, and then we have scrub after, for instance, scrubbing the traffic. Or we can have nscrub filtering the DDoS attacks, and CentOP after the nscrub able to filter, for instance, L7 traffic, or
yeah, we have created this tool at the beginning mainly to protect our own monitoring tools, because the first problem we have seen that when there was an attack, that the monitoring tools were under attack. This was the idea. And then later, as Alfredo said, we have been contacted by people, mostly people that don't have big budgets. Okay, for example, we have which are
nasty providers targeting at human rights organizations.
So they are hosting these people that are always under attack. So it's a good place to run our software. So this is why we have decided to have this combination. And probably we are thinking to merge the scrubber with the monitoring tool, because might make sense in some cases.
Yeah. I think, yeah, if someone is interested, we can do an offline session. I have a few more slides, more detail.
And Luca, so, we see working with people that are doing large-scale monitoring. A lot of them are internet providers. A lot of them are web companies. The market for, we're very interested in sort of getting to ntop, the requirements for scrubbers. Anyone know what the list price for a 10 gig scrubber from Arbor, Radware, and A10 is in the room? Probably are some people. No one that works for Kentik? So like,
There's one from A10 right there.
Oh, okay. So we won't say A10. A10 is a better solution. Think hundreds, plural, of thousands of dollars for what's essentially, in many cases, they do use FPGAs and fancy stuff, but what if you could make that, pick a number, either the 2,500 that Luca said or 10,000 or whatever, could you make it economical enough to deploy at every pump, right? For scrubbing, maybe even for monitoring. In our world, it's, could you just make it so that any customer that how fast they're connected to your network, if you get more traffic than that, just dampen it, protect the backbone. And so there's web level attacks and all sorts of fancy stuff, but we're very interested in seeing policy enforcement that people can put everywhere, because we all seem to be in an industry of lazy, dumbass hand wavers who refuse to do source address verification on our packets, and that doesn't seem to be going away. So this might be a good way to find this out. That's why we're interested. So give them feedback.
Yeah. Okay, these are the two modes that Alfredo has described. So in essence, to put monitoring before or after mitigation. So in one case, you do monitoring. So you monitor everything and you mitigate your LAN, so the attack to your LAN. When I say mitigation, I mean that we don't want to filter everything out because it is impossible. Impossible in what terms? We cannot be sure that a certain traffic is legitimate or not, okay? But when we are under attack, the main problem here is to preserve our services. So this is the idea. So we have to discard as much as possible of traffic that we believe it is not good, but at the same time, we don't want to be, too strict. This is very important. Instead, if we put the scrubber before CentOP, first of all, we can do mitigation, and then we can use CentOP for monitoring or for other things like for instance, many small companies, many small organizations are interested in filtering some URLs. For instance, we are working with schools. Okay, some of the things that I have not said is that our non-open source tools, so we give them away to school, to non-profit, to whoever we believe should use them. And this is a good idea. So we give protection, and at the same time, for instance, we filter out the porn stuff or sites that should not be good for certain users. So that's why we want to insist on application monitoring. So we want to detect protocols. We want to detect Skype, BitTorrent. So we want to filter out this traffic, but at the same time, we want to go a little bit further, dividing traffic in classifying the traffic. We are currently talking with companies that are doing that, and to make this a bit more advanced than what it is today. So in essence, the idea is that we want to turn a pure monitoring tool into something more. I've shown you before that we can do egress traffic, and this is yet another example of what we want to do. So in essence, we want to be a bump in the wire. So just to complete our talk, I have some open questions. Probably later, if you want, we can discuss them, or if you have feedback, that would be very important. So, for instance, for peer-freeing, we decided that we wanted to support, as many adapters as possible. But we would like to know if it's a good idea for you to add other features, or I don't know, if you have something in mind that could be useful to application, please let us know. Another trend that we have seen last week is that companies are interested, network manufacturer to generate flows in hardware. I don't believe it is a good idea, but I would like to hear from you if this is good. From one point of view, it is not a good idea because you will be limited to monitoring capabilities offered by the FPGA, and at the same time, I don't see a big advantage in terms of speed because, like I've said, if you're interested, we can discuss later. But CentOP can do 100 gigabit, so 148 million packets per second on good hardware, so that it's a PC with an FPGA-based card. Another thing is that we want to accelerate application like IDS. Okay, so for us, acceleration goes beyond fast packet capture, because fast packet capture is just the first step. So the idea, like I've said, is that we want to have some sort of filtering. So we want to offload to either the card, if the card is able to do that, some of them do, or to PF-ring the ability of pre-parsing the code so that we don't have to parse the code many times, so the packet many times. So for example, here you will see parsing ntop, parsing the scrubber, parsing the IDS. Let's try to reduce the amount of time we are putting our hands on a specific packet. And for software, we are facing difficulties due to SSL, so encrypted traffic. So I was wondering if there is something we can do in order to, let's say, to go beyond this limitation, because encrypted traffic is becoming more and more relevant, okay, in terms of packet per second. And as the speed increases, we would like to know what, from your point of view, what are the metrics that we should support, we should implement in addition to those I mentioned before, like retransmission, network latency, application latency, bytes and packets, this kind of thing. So what do we have to put there in addition to that? And also, we would like to have some feedback, for instance, about the scrubber and the inline capabilities. For us, these are new things, okay? We have done network monitoring for many, many years, but we have been always passive. Being active for us, it's more a personal challenge, because we know how to do it. The software is working, but I don't know. I want to understand from your point of view, if you can comment on that, if it's a good idea for a monitoring tool to become something else, okay, at least to provide monitoring capabilities and other type of capabilities. If this is a good idea, we must stay pure monitoring tool and let other tools do the rest. So this is, in essence, yeah, the idea that we have in mind. And I don't know, Avi, do you want to talk now and later we discuss?
No. After some Q&A, I was going to talk about, with some of what ntop's working on, what we think is interesting about the beginning of the talk. And Jim will have to correct me because I always say ubiquitous, but affordable high-speed sensors everywhere. I got it. So, like, what could you do? Because most of our customers send us flow from routers and switches, SFlow, IPFix, NetFlow. But what could we do with additional data? I have a brief thing on that just to get people thinking. But take your, Q&A and.
Yeah.
There's at least one ntop user in the room. How many ntop users are there? ntop stack. Okay.
So I would like to hear from you if you have some comments to say, okay, this is what to do, not to do.
Something that I'm thinking about is I've used HA proxy stick tables to basically slow down connections that are hitting me too heavily, which are not actually adopts, but is something that we need to break them in a fashion. And for that, you either need to be terminating TCP or responding to HTTP. Having an alert that then can reroute traffic to a slower path, to a different destination IP, doing a different NAT rule, doing something to give it a slow path instead of just throwing it on the floor, I think has some value in still being able to respond to things without just saying, oh, that's bad, shut it all off.
Mm-hmm.
And I'm just curious if you have anything of that sort of capability in your filters, or are they pretty much deny it all, or is there a reroute slow?
Yeah, no, we do. No.
Okay.
Something more?
No.
I mean, like TCP, what are you using?
Okay, at the moment we have a few algorithms, for instance, for checking the three-way shake. So if we detect that the request is not legitimate, we just trunk or send a reset back, and yeah, we do not handle.
Sure.
Yeah, but for shaping, shaping is implemented. Okay.
Yeah.
So we are. One of the things we have learned, at least from the feedback from our users, is that even if people don't usually put the scrubber active all the time, okay, they don't like us to filter traffic when it is not necessary. So some garbage is pleasant to have, okay, because you can see really what's going on, okay. Also because sometimes we might not be right, okay. So it's important that the traffic flows. So shaping traffic is one of the things that the scrubber is doing when the scrubber believes that there is a problem. Okay, we are not using TC because everything we do is in user space, so we totally bypass the kernel. Alfredo has implemented some policers. Okay, so ntop ng, I forgot to say today, I didn't talk about that, but allows hosts to do that. So in essence, we want to say you can assign specific PPS to specific ports, or dynamically the scrubber when believes that it's a good time to slow down specific user base, number of flows, number of packets. We have this capability, but we don't rely on TC. And the idea here is not to assign a bandwidth to a user for whatever reason, a contract, but to slow down people when we perceive that there is a problem. So it's a little bit different. Thank you. Other comments, questions?
Just want to say the metadata example around SSL certs,
yep.
and whatnot. I think that's great if you can do some minimal pre-processing like that, because in theory that kind of opens up the avenue not just to grow existing IDSs, but you're kind of doing enough computation there that someone can throw it into some open source time series database and do some analysis. You're just giving a little bit of an hint. That's really interesting. I think that that makes it more flexible for other tools to consume it. I don't know how those open source IDS tools will do that, but it's pretty neat.
Thank you. We want to do something more than that. Some people said that we should check the certificate more in detail, okay, to understand if self-signed has been signed by others. So, in essence, what I've shown tonight is the minimal set of capabilities we should do for SSL. Okay, this has been the feedback. And I agree with you. I very much like Bro, but Bro is heavy because it has to do many things. So the idea is that at least we give people, some hint that specific traffic is worth to be analyzed, and then later you can say, intend to move it to Bro, and then have really a level detail analysis. Yeah? Thanks. No more comments? Okay.
Okay.
Your time.
So I'll talk just a little bit. I'll give a super speed presentation as a summary of a talk I gave at Nanog, and then a different version that I gave last week at FlowCon, which is sort of, we call it augmented flow. There's different words that people use for it, but the idea of moving beyond sort of the standard of what people think of as flow analytics, including the metadata and some of the things like SSL, just to get people thinking. I can give a link to the presentation, but I'm not going to go into it in gory detail with all the fields and everything. And but first, I guess ask how many people run some routers and switches in production with websites or users or whatever on the other end. Okay, and how many people do some level of flow analytics from the infrastructure? Okay. Anyone have PCAP recorders and some of the security boxes that do that and sort of make PCAP recorders or decoders? So, how many people have the flow data going into sort of their own big data systems for correlation with other stuff? Looking at Maurice over there. Cool. So I just wanted to get a high level background. So let me pull this up, find it and pull it up. So it's a very redacted. So real fast, NetFlow. Does anyone not know what NetFlow, SFlow, IPFix, these protocols are? I can give a brief. So it's traffic summaries of where stuff is going to and coming from. And the basics of it are you aggregate the traffic. But, sorry? Oh, it isn't. Okay, I thought it was presenting. I have a big screen here. There we go. Boom. Sorry. Thank you. So you look at the ports and the IP addresses and the protocol, and then you count up bytes and packets or the TCP flags, and then also look at some other things like the MAC address and the VLAN tag and the MPLS tag and some other things. Then you export that. So there's a lot of different things people can do with it. You can look at congestion, how much do my customers cost, who should I connect to, am I getting a DDoS attack? Primarily on the volumetric side, so not the full range of application attacks that we were talking about a little bit. Even some security use cases. So a lot of these tools people think of as security. What happened for the last 90 days? It's a hell of a lot cheaper to store that in flow than it is for packets. And so, when we started, we're talking with some of the people that Luca was talking to today, and they're like, oh yeah, we have 30 terabits and we want to store flow for everything unsampled. And you're like, well, that's really expensive unless the alternative is PCAP. So people want to do that. Where should I add, to the network? Everyone's seen graphs, alerting, traffic flow. But what if you're generating flow by looking at packets, and especially on the sensor side, or on a server, on a host? So routers and switches, there's a limited amount that they can do, although does anyone have Cisco's that can run ABC, any ASRs? There's routers that can actually do some of this and have support for it. It was a big deal 4 years ago when router vendors said they could do line rate NetFlow, and then 2 years ago when they actually could. Now they're getting moving up in the world. And we think of this as sort of 3 levels, 3 dimensions. Semantics, that DPI, which is the certificate or the host name, or the DNS query, or even response. The application performance, which is the round-trip time of the request or of the HTTP request inside a persistent connection, and the network layer performance. So jitter, loss, latency. We look at, if you could get one metric, we like loss. At Akamai, that was what we use. And so if you take all 3 of those things, there are a lot of interesting things you can do. And again, I'll just breeze through them. In our world, which is more NetOps, DevOps, it's like people usually want. There's some strange people that like to be woken up by their computers all the time, but most people don't want to do that. And what they want to know is there something effectively uses this causing a problem? And if so, where might it be? And the network nerd side, and often they spend more time proving that it isn't the network than it is. And in general, we see especially web companies, people really do want to know if there's a problem and make a public organization to be able to deal with it. But they also want to give everyone the ability without specialized network knowledge of knowing what it is. And so first thing is performance problem, and the application isn't. Don't tell me in the middle. I don't care. I'm not having my dashboards. If it isn't affecting the user, then is it a system problem, application problem, network problem, to do some correlation. So where can you get this? So IPFix, A9, SLO, you can add fields to JSON. How do you get the data off? It's sort of guys start it doesn't really matter because most of the protocols are extensible. But where can you get this data from? So we heard about ntop. To be politically correct, Argus, relatively used, but has really nice network layer instrumentation. There's commercial sensors. Luca was sort of talking about that are $25,000 opportunity you can just watch to a couple $100,000 for PCAP, which deters. You have to have a really big budget to deploy everywhere. But Gigamon, does anyone have packet brokers in their infrastructure? Things that copy packets and buy fewer big boxes. So there's those devices, even some switches. Arista has a build that will let you monitor traffic and send it to multiple devices. And some of those can not only do the standard flow, which is where's the traffic going to and coming from, but also start to do some decode. Right now, Gigamon is just HTTP requests, but they might do some other stuff. But if you look at, has anyone looked at row logs? Start log Suricata. It's got time, ports and IP addresses and protocol. Well, that's like how you organize a flow. And it's got a bunch of IDS stuff, most of which you wouldn't necessarily store, but has the beginnings of all these IDS things. But it doesn't have what most of those tools don't have is the performance side. They don't have the application performance because that's not what they're designed for. But even web servers. Nginx can reach into the TCP info struct and get TCP state. Now, the cheapest place to get instrumentation, especially if it's already, especially if it's encrypted,
is at the load balancer or the web server that is sending the traffic, because it's decrypted and it's sending logs. And what if you can get the network layer data and then configure your host monitoring to not send you data about the things that came from that process? And in fact, in nprobe, you can use sysdig. So you can actually, I don't think you have filters on it today, but in our minds, if you had an Nginx running, you might want to configure nprobe to say, look at sysdig, and if it's this process, like not all 443, but if it's coming from this process that I'm getting logs from, and then take those as different things that are formatted maybe differently, but then put them in one data store. Just a lot cheaper potentially on the CPU. Load balancers, I don't know if A10 is doing this yet, but there's different, Citrix does it. Even some of the, on the DDoS scrubbing side, again, to take that instrumentation and to be able to ship it off, where you've got potentially, so Citrix AppFlow does the URLs, and it does the application performance, and I think it even does some of the network layer performance. I took that out. Cisco AVC, you can say this traffic, now pull, and I'll tell you what type of application it thinks it is and the network latency. So there's some issues, like Gigamon can only do unsampled, and sometimes, like Riverbed has done this for a long time, but they say their use of the templates is patented and copyrighted, so they won't tell you what it is. So, you know, what do you need to be able to do? Your flow tool needs to be able to take some of these fields. And in our world, we designed it going in knowing we want to solve some of these things. And the people playing with their own big data systems and Kafka and playing, you know, it's generally pretty easy for them to get those fields. So what can you do with that? So network performance, you can look at, am I having consistent congestion? And is it somewhere in my network, and can I do something about it? Does anyone remember Sockeye, NetVMG, Route Science from the early 90s? So routing control stuff, like there's a company, Noction, that does that as a service now. So how can you take that and automate out some of the manual of it? And for example, you know, looking at retransmits from a server or from a sensor by AS path, in many cases you can see the whole path or a given hop, where in my network is that, and then maybe try to move it and do something about it. So application level attacks, I mean, you get the URL. Now there's a question of whether you want to store the whole URL and the whole user agent, but you're getting some of the data that you can use to do things that are classically security, at least on the monitoring side, to say, am I having SQL injection attacks and things that WAFs would block? We call it APM Lite. Does anyone have ExtraHop, Netscout, some of the network APM tools? So there's APM, which starts from sort of external monitoring, browser instrumentation, app stack instrumentation, app instrumentation. And then there's packets up stuff, which is mostly appliances. So it's called NPMD, Network Performance Monitoring Diagnostics, or AANPM, Application Aware Network Performance Monitoring. People spend billions of dollars a year on this. So there's no reason that you couldn't do this with the same kind of flow tools, at least to start. And again, the application performance, network problem put together, we think that's an interesting thing. Bot detection in this world, maybe e-commerce bots we see a lot, which is this a real user? And maybe I want to do different things if I'm running a ticketing application. So if you have a common flow infrastructure, you're spending all this money to instrument and collect, we think it's interesting to say, where else could you get data from that's not the switches and routers, and what could you do with it? How you transport it, separate question. I took out some of the things Luca talked a little bit about. We use a binary protocol to transport it because we think it's super high speeds. The templated flow protocols and compressed JSON or JSON is just a little bit more CPU than we'd like. Anyone use protobufs? So the guy that did protobufs made something called Cap'n Proto, which is efficient C structs, and we use that. Might wind up releasing some tools that basically take Nginx logs, bro, do some of that translation using that as an efficient transport mechanism, but don't really care what the protocol is. It's just a question of get the data, what could you do with it? And, we think that's sort of interesting, especially if you've got the security group, the NetOps group, the sysadmins, the application group, performance monitoring group, put them all together on one platform. So questions, comments, anyone torture their logs or devices to get flow-like stuff today?
I might be too much in the startup web space, but I have been fooled into using Elasticsearch for this. I think it's been a good good thing. I'll take my everything from my DHCP logs to my NAT translate table copies to some NetFlow data. But that gives me the visibility, and then I can add in other application layer stuff. I just worry about having yet another source. Anyway, I like what you said about taking it from the host, because that's to me the most efficient thing. And people don't have networks anymore. You can take your /24 and bring it to Amazon, and they'll host it for you. There's no longer this need for network monitoring tools and network specialists. I'm offending everyone, including myself here, probably. But I've seen it all just, now it's going to be in a small Docker container, which may not even allow you to have an instrumentation layer. So is that, how are people adjusting to that? I mean, not having a network infrastructure anymore?
Well, I would say one, we've seen people use Elasticsearch. Some of the challenges become like, if you want to put BGP data together with the flow, and it's like many things, it's not good at joining after the fact, so you have to sort of know in advance what you want to do. I'll take a counterpoint and then throw it to the floor, which is all the people that make revenue, except Netflix because they're crazy, run away from public cloud as soon as they get to scale where it matters. Because of performance and cost, not security. People trust VPC, people trust Amazon, and by all I mean, like many. And then they start to run their own infrastructure, and then they go, ooh, where's my apt-get install scale out thing? But certainly there are people, major companies that are moving all there, and classic enterprise, certainly want to just abstract out the network layer. And so I'll let your question stand, which is, do people think that the networkless world is coming? And if so, what does that mean for monitoring? If I can rephrase your question. Yeah.
So continuing on Bill's point, and mostly a network geek, I've spent most of my career running networks that forward packets to other people's servers that I have no visibility into, so flows the only way to get to that. But I ended up running a CDN for years, do a lot of analysis on that, and I think, again, from my network geek perspective, it was kind of a little bit eye-opening to be able to go, I no longer need to deal with this flow sampling. I no longer need to be, looking at things by /24 or not seeing URLs or whatever. I got these server logs. I can see, granted, if it's DOS traffic with garbage or something, I probably can't see that on the server logs, but at least, if legitimate traffic, I could either analyze flows and be very vague, or I can analyze the server logs and get exactly what I want out of them. And so, I think for those who are on the server side, that's pretty cool and pretty easy, and it's still useful to have good visualization tools for that, and be able to map those addresses and server logs to ASNs and so forth. But it gives you a lot. At the same time, though, even as everything moves to clouds or CDNs or whatever, all these things still need to plug into networks somewhere, and you may have fewer big networks and perhaps fewer people working on them, but there's still, somebody who needs to know what's going on at the network level.
Yeah, we've just seen a lot of companies, they do it the old-fashioned way. They buy some servers, they buy some switches, usually, Juniper or Arista, and get some MXs and put some servers on. Very few of them for web-type stuff use OpenStack. They just provision stuff, and but then need to work. And some of them are hybrid. So did anyone use Boundary? Does anyone use Boundary? Okay. Yeah. So that was a long time ago.
I love the concept with a boundary, and you may kind of go looking at your application holistically about these are the requests coming in. This is the generated cache hits. These are the cache fails. This is the server equivalent CPU load on my slaves and my masters, and this is the equivalent load on the disks. Having a full view of here's the thing coming in.
What did it do? Well, it's 360.
Yeah.
Something that matters, it's a performance problem. Where is it? It's application, servers, local network, remote network, something, or randomness that you'll never be able to figure out. So, well, and the reason I raised that to answer your question, We studied Boundary pretty closely. BMC just bought them, because they started before we did, and they're doing Flow in the cloud, or they use their own cloud, like we use our own infrastructure. Their backend was summaries only, so it was only top talkers. You could define queries like in Arbor, but you can never look back in time. And that's like Arbor customer number one complaint is, let me look into the past, not just into the future, and Boundary was the same thing. But the thesis that we've heard from people that worked at Boundary and venture capitalists, which is the land I also live in, talking to, was they showed people in Amazon detailed network cause performance problems, and then Amazon says, okay, thank you, reboot your machines, use a different availability zone, whatever. So my thought is that they got a lot of users at a great UI, they didn't get a lot of renewal because it wasn't very visceral, and then they tried to go towards the APM side. And they just were competing with New Relic and AppDynamics, but I don't know. That's our theory. And so for us, we tend to focus on people that are run at least some of their own infrastructure, because then they have the visceral pain of, oh my God, what do I do with this stuff? I don't want to figure this out. But I think it's an open question. We're actually staying away from the people that just do server. But even though we could, it's all the same stuff, And that's why, but we do think about how could you monitor that web server without having to decode all the PCAP, which is, like Nginx from this, ICMP, and from this, maybe put it all together. So cool.
Yeah, I got a comment on the, merging together the application with this networking. Well, I could have talked about it a decade ago. I apologize on the name, but it's called Bits and Bits.
Mm-hmm.
So you can imagine what the video content was.
Yeah, Denny's hard drive.
Exactly.
Right.
So this company, the challenge was when I started, it was all single home with Kogan. This was a decade ago, so Kogan was...
I was there at that talk. I think,
and the challenge was convincing management that, hey, this is a slow ISP. And that particular site, people paid for all the content. It was extremely profitable. A couple blocks away, they did 40, 50 million a year. So they're doing quite well, but we were buying Kogan. And so I was trying to convince them to get better transit. And so what I ended up doing, and this is really happy, and this is a decade ago, is normally in Apache, it logs the response time when the request is done.
Mm-hmm.
But you can add a log, something called mod log per request.
To do start and
exactly.
Yeah.
So we would then have a cron job to show IPBGP in the router.
Mm-hmm.
And we put a little bit of Postgres, because Postgres has site data type, and a little bit of MySQL because the queries were faster. And basically what I did is I made our virtual graphs that said, okay, if the next hop is this particular ISP, and then I look at all the eyeball ISPs, so BT, Cox, Comcast, Charter, and then the next day I would change the route maps, kind of an offline FDMT, if you will, and take a different path. And it was really interesting because we could actually tell when an ISP would turn on their traffic shifting. We could tell our customers, if you want to view our content, here are the hours in your time zone when you can download it at full speed. Because our motivation was, and again, this is sort of, kind of pun, to get them off our servers as fast as possible.
Right.
Because they're consuming bandwidth that we're paying for. And frankly, most people don't go past the first page anyways when that style of content. But it was really interesting to me, the idea of taking network and application data and merging them together. It's extremely powerful. I work at a switch vendor now, and the challenge for us is that we can produce all kinds of great data, whether it's Excel or whatever. But at the end of the day, it's really that application visibility. So I think you're on something, but those two mirrored together is extremely relevant. And if you can make that more consumable, whether it's Nginx or Postfix logs or whatever, I think that would be very powerful, because right now, a lot of that stuff, like you said,
separate tools, separate groups, separate tools, all disconnected.
Focused,
and
agnostic to the network, but the network can be the cause of a lot of it.
Right.
You just don't see it. But like New Relic, you don't really see that. They don't think about it.
Yeah, and AppDynamics is building something, but it's not for. It's going to be aimed at a different group, and it's going to be pretty sucky, but because they run VMware VMs for people, that's their cloud. Is they make you a custom set of VMs. But I think it's very interesting, and frankly, I think ultimately there's no reason that there needs to be a difference between APM and the NPMD and AANPM. Anyone heard of a company called Akamai? Where I worked? Okay. So Akamai has this thing called Query. It's SQL access to all their time series data. That's, you can think of it as what we'd call a streaming database now. It's imprecise, geographically distributed, and that's pretty much what Akamai uses for its infrastructure monitoring. And you know, this was a question that they needed to answer, was how do we get all this data and be able to know actionably, are we a problem, are they a problem, you know, and put it all together. And, you know, but that kind of bus and putting all the data together, just, you know, people historically have had to write it. So, but the interesting thing about Query is Akamai said, because it could, it was greenfield in 1998, let's instrument the application by pushing metrics, but also when I started, there were these two guys who, prima donnas that had written first versions of most of the things. They were like, I am out of here. They took my SSH keys away from the network. Screw that. And what Akamai said was, no SSH to servers. You must make callbacks in your application functions that you can SQL request in to trigger and get the data out. Like, and for debugging, but also for instrumentation. So if you think of a world where you could do that, and you can stream metrics, and if you look in the startup land, there's people doing that, and you send it, as you said earlier, to a time series data store. Okay, so now you've got some application instrumentation. If the app, so I'm old, so I write like C code, so I don't know about these JVM things, but if you instrument the app environment, and that's the thing that I think we miss from the people in this room building tools, is we're not going to go make the PHP and JVM app instrumenter that New Relic did, but everything else, you can get the packet level, you can get the metadata, you can get the network performance, you can get the application performance, you can get the servers to your time series, you can get the functions every time they're called. You've basically got the packets up and the app over, and I think that's really interesting, and we may or may not have plans to do that, and we work with web companies on that. But the market that we've seen, or the people that run their own infrastructure that are most interested in this are ad tech companies. Does anyone here work for an ad tech company? So, okay. So, 50 millisecond SLA on the whole thing, even the part that's not you. Like, it might be the exchange and the supplier, and you're the buyer. Or you might run the exchange, and it may be every transaction. Sometimes you're 1, 2, or 3, or both. And so then the question is, yeah, sorry. Yeah.
How fast is it to move out of Amazon? Because we have no view on it.
Right.
I mean, I'm summarizing.
Yeah.
People are working from Amazon.
Yeah.
Not for me. It's just like we have no metrics.
Right.
Like we just get aggregates of Ethernet interfaces, and there's nothing we can do.
You could get this display, which is like by ASN, where are your performance problems? And you call Amazon, like.
And they say they don't care.
Right, exactly. Right? It's the same thing as.
We can totally told them.
Right. So, but ad tech are but we have some people we're working with that do a terabit of 5 packet flows. So, the existential question for flow monitoring is, how much traffic is the flows? And you go, well, that depends. Less in the case of S-flow, but in terms of standard flow analytics, is it DDoS traffic, or is it, gaming video with a 30-minute, flow timer? But then, the next question is, where do you go put the application on top? And that's, it's just a question of how detailed do you need to be for that to be of value to people. But we've definitely seen people writing their own applications for that. So, yeah, I just think it's interesting. We like to talk to people about that. Some of it's roadmap. And there's security, Anyone used Langcope? Anyone work for Cisco or Langcope? Okay. So, it's a box vendor of the people that could do unsampled long-term flow retention. It's what we do. There's a software company, FlowTrack, and then Langcope, and then the Riverbed bought a company that does, I can't keep their product names. Mazu, okay. And so, Langcope's one of those companies. If you go to Cisco, even before they bought Langcope, and you ask 20 people in their big booths at Interop or Cisco Live, like, what do you do for flow? Like, oh, I want to do SDN. What's the network doing? Like, oh, you don't need to do that. Just do SDN. Then they tell you nothing, and then the security people would say use Langcope. But that's flow, threat feeds, and scanning and some security dashboards. So again, it looks like the same thing. It's like, but we're just trying to figure out like who are the users, what are the exact use cases, because it can be hard reading the marketing and then turning it into technical requirements because so.
One other thing we've been batting around, wearing my switch vendor hat on here, is SFlow is great for like counters and stuff like that, but there's a lot of things that happen on the network that users want to know. So we've been experimenting with basically dumping things that are not within SFlow. So spanning tree, BGP routes, all that sort of stuff. And we've had a lot of experiments putting into console or Redis or Elasticsearch. And we've done every hipster database, you name it. We've done it. And what's interesting there is that we're using that as a troubleshooting tool. So the idea is that, just like you said, there's some people that like to get paged, and then you kind of reach puberty and you don't want to get paged. That does occur. And I think for us, it's interesting. It would be interesting to hear from you. If you had a network vendor that could give you data that's not within SFlow or NetFlow, what would it be? But because for us, it's states within like the IDP, all those sorts of things. And we see that we basically stream it every 5 seconds. And then when something's bad, we just have a Python script that reads that key value store and says, oh, by the way, spanning trees, change state, or this port went a lot faster. You should look at that. And it'd be interesting. You focused on the application side, but assume you had a clean slate on the networking side. That would also be interesting to me because some of the chipset vendors are exposing a lot more of that stuff, or the OS is just an app away, so you can do whatever you want.
I have an answer for you, but I always talk too much. So anyone else? Yes.
I'm talking too much here. There was a paper, I think, from Facebook about microflows, like completely trashing their database. And it was basically getting buffer overflows on their switching hardware. And there's not a lot of visibility into that if you're not paying attention to it, especially because it can happen in 10 seconds. And then you never saw it.
10 milliseconds.
Right. So that's what I would be, because I want anomaly detection for things like that. And I know that's a generic empty statement. But very bizarre network traffic that doesn't match pattern is what I want to do.
Mr. Espel?
Certainly 10 seconds is well within the resolution of real-time SQL analytics.
Yeah, 10 milliseconds is that.
You could easily, if Facebook had more tools, they probably could.
Well, they showed it on the
case study, actually. And I think they just weren't getting granular enough.
Because I think it's milliseconds.
Or didn't even have it turned on.
I thought they were able to enable it on their hosts, on the server host as well.
Yeah, it's easier to resolve if your neighbors directly on the link that's affected. Traffic inference from the edge is much higher if you measure everything and every port. Then it's a lot easier to figure out. And one of the benefits of SFlow is actually that it is stateless. So if you have like ECMP instabilities, SFlow will correctly report them. It's not going to try and collapse 10 paths into one record. It'll show you each individual path. And so you can see very accurately where the packets are coming from and going to on every hop in the infrastructure.
Mr. Applegate, what was the time scale at Cloudflare with the microbursts that you were seeing?
The time scale, they were saying it's probably like 10 milliseconds.
Yeah. And so that gets back to the forwarding plan. So does anyone know, I think it's Greg Farrow, one of the Packet Pusher podcast guys. He was here earlier and we were talking about, Network Field Day, yeah. So he's here for the Network Field Day. So he came by and he educated me and we argued and like that. And so what he thought was the way, and I've heard this from some of the web scale guys, which is funny given your hipster database. I just think of but is Redis web scale? Does it scale? Does it web scale? Is, to get that, imagine you've got the packets coming through and internally or even cross switches to have some tagging built up of interfaces, what the queue depth was at the time that it came out, and then once it exits the magic mesh or whatever, or maybe it's even intervendor, be able to build the aggregates or even have some rules like, sort of in Luca's world of let's have the policy and we want none of this, sampled aggregates of this, all of the SMTP because I'm debugging that right now and then stop. and be able to get that. And I think actually streaming summaries from the edge with policy-based, let me pull samples, or even all of, that's what I think, would be great to have support from at the switched level. Then to be able to push that. From you guys, I've talked with you about this. The Broadcom, the old series Broadcom chip, and before Kentik, I was building network sensors, and we actually put something on the Junos V App Engine, which was a Intel blade that they were going to make, and then they killed. So, but firewall filters have the same problem as Broadcom. You can do packet sampling, but your CPU, just thermal energy you can get for Intel CPUs in a box that can do terabits, you're not going to get CPUs that can do terabits of traffic. So you can't send all the packets to them. But packet sampling doesn't let you do this augmented stuff unless it's single packet flows. So what I'd love to see from the switch vendor is let Luca put, a client that can get 1/1000th of flow hash, and say headers or packets for 1/1000th, all the packets in 1/1000th the flows. So 999 out of 1,000 times you get nothing, and that way you can look at network performance, you can retransmits, like jitter, application. I think that'd be really interesting, because then you could do the NFV hoo-ha by turning up something on the switch. And if it's too much, you change the sample rate and then get that out too. I think that'd be cool.
Yeah, the metadata comment I think is really interesting. Like someone mentioned ECMP, and it's like it breaks a lot of applications. And as a switch vendor, or a network vendor, if we don't build switches, what's interesting is that the amount of requests we get for like, oh, I want persistent ECMP hash. I probably hear that 8 times a day. Oh, well, some server goes away. Don't rehash. I want anyone to know something went bad. But that data is never measured. It never gets out to any of these management tools. And so, we're looking at like basically exactly what you said of streaming. Kind of what is the switch doing? Kind of like with the SSL example. Like if Bro says, yeah, this person went to some HTTPS thing. Oh well. But at least if you can get like the cert name, and maybe you do a lookup to see did it expire or not, and whatever, same sort of thing. I think we could do that.
I'm not promising to build this, but if you could stream out what the hash function was and which link had which modulo, right? Even if you're changing it, then you could back correlate with the TCP retransmits by network layer link. Okay, so if you could get that, we don't have any customers that have said go build that. So, but that was a big web company requirement when looking at a web company. Like early on when I was like, what does SDN mean to you? And he's like, we've got 40,000 10 gig links in our network, and the SFPs don't always die. Like in the old days, in the 90s, shit was either working or rebooting or dead. And then this whole confused state entered the network world where things were not quite working quite right. And so imagine you've got enough devices that they're going to fail in the most spectacularly strange ways. How would you do it without, and he was saying, like, we have to go turn off all the interfaces and see if the problem stops. Like, how would you do that? So that's why the control plane data is interesting. Now, if you make it static, then that's super easy. Right, because then I get that once, you don't have to have the time, whatever.
Right, yeah, we've been thinking about this idea of taking some of those DevOps approaches to monitoring network devices. So, for example, you don't need to stream back and say, okay, here's how many bands the power supply is.
Right.
You only stream back when the power supply disappears. So we're doing like, Etsy's got this thing called Logster or something like that. It's some sort of a stats type where it basically takes syslog data and generates metrics out.
Oh, cool.
It's like our whole goal is like we want to get the best entity. That thing is a joke, right? It's embarrassing that that's the modern tool. And so it's interesting, this idea of getting telemetry off, and if you've got a wireline protocol that's kind of generic, that's really interesting to us, because we don't want to be fixed to like, well, we picked Redis, and those hipsters moved on to another thing. So we'd rather just have some common transport. I think that's really interesting if you could get other tools besides yourself to consume it. I hate to say that, but
no. I think that what you do is define the metadata, and then say you want it in JSON, Kafka, awesome. You want it in we call it Kflow because why not? In Kafka, fine. SSL, which is how we do it, fine, right? It's really what's the metadata, and then people can argue. We've looked for serialization, which is this wireline binary packing, so you don't have to do all this ASCII shit for this beautiful binary data, and couldn't find one that was, we wanted in particular C and Go and C++, both disk storage and they call it, API, like over the network, where you could have effectively templates and have optional fields, and was good, and we couldn't find one. So we just went with something where you can't actually delete fields and make them optional, but it zero packs them. So it's much better, but
So it's a minimal scheme.
it's a minimal scheme. Well, it's not quite minimal. We can talk about this afterwards. I could show you. If other people are curious, I could put it up. But
I have a generic question.
yeah.
This is more enterprisey, but have you gotten any correlation tools with ntop or with your systems about looking at a Wi-Fi network? So when do clients roam? What are their signal strengths at those times? I mean, that's a pretty enterprise answer problem. But I spend a lot of time. Ubiquiti stores all that data in a Mongo database that you can pull off the controller. So I grab that on a pretty regular basis to improve my Wi-Fi network. Anybody?
Not me.
Very enterprise.
Yeah, we have some support for meshed networks, so not Wi-Fi.
Yeah.
But we have support for the special NetFlow sent out by Cisco Wi-Fi access point.
Right.
The idea is that at the moment we are supporting ntop and we want to improve the right ntop header, so we can create statistics about the signal strength and the antenna.
Right.
Something we would like to do is to put this also in NetFlow, but at the moment we don't have that.
Some wireless access points support as well. And it gives you things like signal strength, as well as the packets and stuff.
And you get MAC address, as part of that. So.
Percent train, that's the packet.
Yeah.
Because it's in the access point, it's the decrypted version of it. So it's pretty good data. Not important for us to put the packet, I think, Fox.
I was hoping to use it to be more directed about forcing clients to disconnect and reconnect to a new access point. And I'm sure those are patents with ideas, but it just seems like a logical. It's a network that everybody's experienced bad performance on pretty regularly.
Especially with Macs.
Sure.
Yeah.
So on wireless, you have to be careful what statistics you actually get out, because I know last year that discussion at IETF on the HomeNet talk about it. Home is most access point. I mean, you get basically signal strength from receiving the other side, but you have very hard time to know what the other side receives and all that stuff. We ran into the issue when we tried for ISIs having like metrics changing based on like signal, but we just couldn't really get all the information out. So with the HomeNet, basically they choose table afterwards, which does like measurements while sending traffic along the whole day. So it's a challenge there in general wireless to get all the essential data out.
Yeah, that's one of the things that SWAT gives you is the actual airtime. It's perception. It's not a bad thing. It's how long you occupy the radio. And so it tells you, how many times that packet you transmitted, and also how long you didn't occupy the radio successfully left the device.
Which AP vendors support that? Do that.
In fact, in proxy, okay, removable that.
Okay. Cool.
HP actually couldn't develop that spec.
Cool. So we have any other ntop users, wannabe users, feedback for that, people thinking about doing sensors. I mean, our goal is to work with customers that do router and switch based for now, and make it cheap enough that it's just we have a pile of them, we just FTP them a sensor, and they stick it in, and see whether we get good data out of it, which is much easier when it's not a $50,000 box. But that'll be a 2016 thing for us to play with.
You asked about packet generation. I was always trying to create my own Pixies, and then more about trying to create smart bits, trying to do protocol validation. That's very vendor specific or next-gen hardware testing specific. It's probably small. overflows and contests here. But again,
Yeah, one of
small market.
No, one of the things we have inside the different toolkit is the ability to generate traffic. Two types of traffic. One, we can generate synthetic traffic, so you can say, I want to fill up this pipe with the packets from this range to this range, this port, this port. Sure. Or let's say at this speed, so 1 gigabit, 2 gigabit, whatever. Or you can generate your own pickup. Okay, you write it somewhere, you generate it with estimates, market, whatever you like. And then we can reproduce it at line or at the speed you like. These are the two options we can offer. Of course, our tools are also accelerating Austinat, for instance, that is another tool, traffic generator. But for us, it is important to generate traffic that it is very precise. Okay, of course, we do it in software. But for instance, if you go on our blog, you will see that there is a project we have done years ago with Fox Television. And we record to disk traffic, all in software, no FPGA, nothing. And with software timestamp, and we reproduce it at the same time on the network. So it means we have to be very precise, otherwise the television flickers, so you start dropping frames. So there are options. Keyframe comes with those two for free. So please let us know what you think we should add, what's on that.
I don't work for a network vendor anymore, but I still have next yet.
Yeah, I do have it, but at 1 gig. Now we are facing with 100.
So I do have a question about interest in meetups in the future, but whatever anyone would like to talk about, burning problems, vendor flames, solutions that people are looking for, techniques, peer-to-peer, questions, comments.
Thanks for putting it together.
Sure. Yeah, it was actually Luca instigated. He's like, hey, we're coming to the Bay Area. I was like, oh, one of the godfathers of network monitoring? That sounds cool. I used ntop in the past. And so, cool. So, would people be interested in, are there other meetups for, deep network nerding, especially
There's
around?
an automation one that happens kind of frequently. There's a Juniper-specific one that happens on their campus.
Monitoring techniques.
Yeah. It's the only ones I'm aware of. Because we posted it.
Yeah. The vendor. So.
Sorry.
Yes, so if there's potential interest, we'd probably try to find some people to talk about different topics, and we're happy to host, or other people can, but also there's a lot of users of networks up in the San Francisco, so thought that would be interesting to not have everyone have to drive south. Well, apologies to people who drove north, especially on a rainy day and whatever, but we'll probably give that a shot again and put it in the same series, so everyone should get notified about it. But
yeah, I think it fills a good need. I think there are a lot of us around here who work on this sort of thing. Running into each other, and I don't have some faraway places. We really should get together closer to home.
Yeah. And if anyone is not on the CA Geeks mailing list, it is for applied nerd practitioners, not just about network, but it seems like 2/3 of the folks are network around people and can introduce you to how to get subscribed. And it's CAGEEKS.
It's mainly discussion about airplanes and cool ideas.
Yeah, it's random bullshit, but libertarian, nerd, traveler, network bullshit list.
And there used to be network geek lunches that were organized on there.
Yeah, which I never went to. Cool. Well, thanks everyone for coming. We have pizza, and more drink, and wanted to make it not about, oh, here's our commercial stuff, but happy to show anyone that wants that too. And last call, questions, comments. SDN is bullshit, to be discussed next time. So, thank you.